Today we'll be working on decimal equations. Please copy the standard benchmark indicator on a clean page in your math notebook. The student will model and solve algebraic equations. Solving decimal equations, addition and subtraction. You can solve addition and subtraction equations involving decimals by using mental math. You can also work backwards to solve for the variables. We're going to look at both ways to do that. So the first way is to look at x plus 5 3/10 equals 6 6/10, and we have to think what number equals 6 6/10. So we use mental math, and we find that 1.3, or 1 3/10, plus 5 3/10 equals 6 6/10. Then we check to see if the equation is true, and it is. We can also work backwards. To work backwards, you start with the answer, and to get to the beginning, you can subtract the known, add it, and this will give you the same answer. So in this case, they took the 6 6/10 and they subtracted the 5 3/10 and got 1 3/10. And that's what we looked at on our last set of equations as well. So here, what we've done is we're getting the variable by itself by reversing the operation used. So we subtracted 5 3/10 from both sides. So you get x plus 5 3/10 minus 5 3/10, which cancels it out and leaves the x by itself. And then you have the other half of the equation, 6 6/10 minus 5 3/10. And that gets us x equals 1 3/10. So whatever you do to one side of the equation, you have to do the other, just like when you're making equivalent fractions. And always plug the answer back in and make sure it works. Equation problems should be self-checking. If you put your answer back in and it doesn't work, you know you did something wrong and you need to check your work. Try it. Solve a minus 5 2/10 equals 3 1/10. So to get a by itself, we're going to add 5 2/10 to both sides. So 8 3/10 minus 5 2/10 equals 3 1/10. And then we plug it back into the equation to make sure it works, which it does. For the second one, we have 5/10 plus b equals 2 3/10. So the nice thing is addition is commutative, so we can change the order of that to make it easier to get rid of the 5/10. Now we can easily subtract 5/10 from both sides to figure out what b is. So b equals 1 8/10. So we're going to plug that back in to make sure the equation works. And we can see that it does. For the third one, the variable is being subtracted. So to figure this one out, we're going to take 8 6/10 and minus 4 3/10 to figure out what that missing number is. And in this case, it turned out to be 4 3/10. So now we're going to plug it back in to show that the equation is true. Now for g and h, we need to solve. So for g, we have d plus 1 8/10 equals 2 9/10. So to get the d by itself, we're going to subtract 1 8/10 from both sides. So D equals 1 and 1/10. For H, we're going to rewrite it so the variable's in front, so we're going to do E plus 2 and 9/10 equals 3 and 5/10. Because addition's commutative, we can change the order. Now we're going to subtract 2 and 9/10 from both sides to get the variable by itself. So our answer becomes E equals 0 and 6/10. For I, we have $1.95 plus F equals $2.15. So we're going to reverse the order so that we have the variable first. And now we're going to subtract $1.95 from both sides to get the variable by itself. And then we find out that F equals 20 cents, or $0.20. For J, we're going to subtract 75 cents from both sides to get G by itself. And $1 minus 75 cents equals 25 cents, so G equals 25 cents. For K, we have H minus 2 and 4/10. So to get H by itself, we're going to add 2 and 4/10 to both sides. And when we do that, we find out that H equals 4 and 5/10. For L, we have 35/100 minus J equals 25/100. So since the variable is being subtracted, we're going to take the 35/100 and subtract the 25/100 to find it. And when we do that, we find that it equals 10/100 or 1/10. So J equals 1/10. Please make sure you've copied down all of the work and glue this page in your math notebook.